your preferred partner for custom software development and technology outsourcing. We offer state-of-the-art customized software development services that are client-centric, flexible, and secure to empower businesses.
Well, good morning. My name is Steve Baker. I'm with Core Wireless. And I'm going to talk a little bit about putting together a strategy for selecting a connectivity. At Core, we work with companies to bring their IoT solutions to life. IoT deployments don't come without challenges. Challenges like sourcing multi-location, multi-carrier, and multi-technology connectivity. As a single source provider, our focus is to address these challenges by providing a portfolio of services, beginning with managed connectivity from major providers throughout the world. Our portfolio also includes a full set of lifecycle management services, beginning with technology evaluation and selection, through design and deployment, and covering ongoing management with supply chain and support services. So key challenges and questions about selecting a connectivity option will differ depending on where you are in the process. For example, in the early stages, focusing on a proof of concept or pilot study can give you good insight about what types of connectivity will best fit your application and business parameters. During this phase, questions come up as to how to properly assess the coverage needs and network technology, or what technologies require device certifications or regulatory approval before being deployed. This is also the time to understand how to select the right partners and providers. If you're in a growth phase, the focus turns to more operational and financial questions, like how to manage logistics across the multiple supply chains, or how to establish your support processes and link them to your provider support. This is also when initiatives are expected to begin to return an investment. And when reaching the scalability phase, it's about streamlining and automating your processes by integrating with data streams and solution management from your providers. This is also where having an analytic strategy will enable you to capture and act on information required to provide control and management of your solution. So when evaluating a connectivity option, there are a lot of possibilities that you can select from, and it can be overwhelming to wade through the technologies and terminologies and properly assess a best fit. Many solutions involve multiple technologies and multiple services from the outset. But even if you're deploying a single technology initially, you'll more than likely end up with multiple services, especially as you grow into new markets that require different coverage, or add new features to your solution, or you're expecting a technology sunset. And the complexity grows with each new technology that becomes part of your solution. One way to assess connectivity options is to begin with a set of attributes that are common across several technologies, and then align those to the specific business and application requirements. These attributes can vary widely on the options being assessed. For instance, data rates for some technologies are as low as tens of bits per second, while data rates for 5G can peak out at multiple gigabits per second. And this variation in data rates will typically correlate with the range of costs associated with your recurring fees and your modules. Density will determine the number of devices that can be deployed within a given area, where coverage will determine where you can get the service. Features can include things like support for voice, quality of service, mobility, or network location-based services. And power management for battery-operated devices determines the overall lifespan in the field. Aligning on a set of attributes like this is a good way to narrow down the connectivity options and help you ensure that your selection will create the expected outcomes. Another way to identify candidates for connectivity is to look at how the market sees the technologies evolving over time. The majority of the IoT connections fall into the short-range category led by Bluetooth, Wi-Fi, Z-Wave technologies. But from a cellular perspective, the LPWA technologies led by narrowband, IoT, and LTE-M show the highest growth curve through this decade as part of massive IoT. with 4G and 5G making up the remaining connections. Looking at some inflection points along this timeline, eSIM technology is expected to reach nearly $1 billion of revenue by 2024. The adoption rates continues to accelerate for eSIMs, making it an essential part of any connectivity evaluation. The massive IoT category will continue to accelerate as it builds on deployments in the 4G era and will continue as 5G rolls out. It's expected to account for 2.7 billion connections by 2025. And 5G is expected to be carrying nearly half of all mobile data in that same time frame. So in addition to supporting gigabit data rates and the density to serve 1 million devices in a square kilometer and supporting millisecond latency, what 5G really does is set the foundation to realize the full potential of IoT. It will enable new applications that require real-time reliability and network performance, such as performing surgery remotely. 5G will also enhance the promise of private networks, where attributes like security, reliability, and latency can be specifically configured for the needs of applications like industrial automation and remote control of heavy machinery. 5G is being deployed in several phases and has already begun to support enhanced mobile broadband services in many areas. With modules and chipsets that are already available, routers and vehicles are already beginning to benefit from experiencing the same level of performance that devices with wired connections have. Most IoT devices don't require the bandwidth that 4G and 5G support. So LPWA technologies were developed to create more cost-effective, low power, and low bandwidth options. These technologies are well suited to ultra-low data and message-based deployments, including smart metering, smart cities, and smart farming. Cellular standards for LPWA began in 2015 for LTE-M and NB-IoT. And in that same time frame, the LoRa Alliance was created to promote standardization and adoption of LoRaWAN. LoRaWAN shares similar characteristics with NB-IoT, and it's easy to deploy in rural and indoor use cases where cellular coverage may not be as strong. These technologies also have exceptional power management capabilities, supporting up to 10 years of battery life for devices. These technologies are already deployed with 4G networks and will transition smoothly into the 5G world, making them attractive options for massive IoT applications. So generally, a new generation of cellular technology comes along about every 10 years, and they last multiple decades from first release to sunset. 4G was introduced in 2008 and is expected to last for at least another decade, and possibly longer by sharing spectrum with 5G. So it's true that some new IoT use cases will only be possible with 5G, but most others will continue to work quite well with 4G technology. 4G has the bandwidth for most applications today, and it's currently a more cost-effective option than 5G. Many devices over time will be developed with both 4G and 5G, making for a smoother transition. 4G may even experience some performance improvements as more consumers' traffic shifts to 5G networks. So many IoT initiatives struggle to get past the early phases of the project. Companies need to plan to address key areas of their organization to ensure they have the experience needed to overcome potential missteps in early decision making. As solutions grow and new technologies are introduced, there's a need to consider additional resources to manage the growing number of providers and to manage the increasing number of interconnected systems. There's also unexpected complexity with end-to-end security across so many systems and implementing a complex supply chain process involving so many suppliers. And to build to scale, the supporting vendor systems should be integrated in your company's operational and back office systems to positively impact the total cost through process automation. A large percentage of IoT initiatives prove to be more difficult to implement beyond the initial concept phase. So any practical part of a strategy is to leverage partners to bring immediate expertise that you need while you're building your own IoT ecosystem. Potential partners should be able to provide a broad base of capabilities that help you navigate beyond the early stages of your project. You can achieve the greatest benefit by selecting a partner at the very earliest stages of your initiative. So reviewing our phased approach, showing how CORE addresses some of these common challenges, we typically first start with looking at eSIM technology. The ability for eSIMs to change services after initial deployment enables customers to grow into new regions with new services without touching the device. It also provides a level of future-proofing as technologies sunset. CORE also leverages an advanced core network enabling finer control over telecom capabilities, which allows us to target application requirements more precisely. It supports localized breakouts, addressing data sovereignty concerns, and improving end-to-end latency to anticipate the 5G rollout. It also enables network slicing in private networks to provide increased security and dedicated resources for IoT applications. So CORE has combined these capabilities with our suite of connectivity and managed services to ensure our customers can deploy, accelerate, and scale their networks. So I appreciate you joining me for this very brief presentation. And I'm going to bring Carl back up here so he can give you more.